Hello, myself Manashwini. Today I am going to discuss regarding combining systems and databases, a search engine retrospective. Today we are going to discuss the introduction, what is problem, importance of the problem, and what are the principles of DBMS that can be applied while designing data intensive. And is it really hard to design a data intensive? And the challenges faced while designing a data intensive, and the main contribution of the data intensive, and what is the approach, and what is the validation. Introduction. In this paper, the author discussed the difficulties and methods used while creating a search engine that can manage the large volumes of data and efficiently handle multiple queries. The author asserts that while search engines draw upon the concepts from database fields, they should not necessarily be dependent on the current database techniques. Instead of that, the paper has proposed a search engine design that utilizes the principles and language of database community to create system that can handle sustainable amount of data. Problem. In this paper, we have tackled the issues of the search engines that have been inaccurately labeled as database or the DBMS. Despite their capabilities to handle massive amounts of data and process queries, this paper also contains the search engines that are first for the several application-specific data systems which are being created by the systems community that must utilize the database principles without a delay, without necessarily relying on the present database implementations. Why it is important? It is important because search engines are the most extensive data management system globally, processing more than 3 billion documents and responding to over 150 million queries daily. However, despite their size and the complexity, search engines make little use of traditional database management systems due to the semantic mismatch and the need for the high availability over consistency. And here also the author argues that search engines should use the principles of databases but not the artifacts, and also proposes three key principles. They are a top-down design, a data independency, and the declarative query languages. By understanding the challenges are faced by search engines and how they differ from the traditional database management systems is important for designing and building effective data intensive systems. What principles of DBMS can be applied while designing data intensive? Um Top down design. The traditional system approach is delivering capabilities to unknown applications, while DBMS follow a top down approach, starting with desired semantic like ACIG and building mechanisms to implement them. Similarly, search engines are also whole designs with different semantics, but their mechanisms follow those semantics. Data independence. Data is present in sets that do not contain pointers. This enables the evolution of representation and storage, simplifies recovery, and enhances fault tolerance. Declarative query language. The use of this language is to define queries that says what to return, but not how to compute it. The absence of how is a freedom that enables powerful query optimization. We do not, however, use SQL or a DBMS artifact, but we do use the structure of DBMS with a query parser and a rewriter, a query optimizer, and a query executor. We also define a logical query plan separate from the physical query plan. Is it really hard? Yes, the problem of designing search engines as a data intensive system is a hard problem due to a large amount of data that need to be managed and high query volumes that need to be handled. And also the paper proposed that search engines can benefit from using principles from databases such as a transactional consistency, a fault tolerance, and the query optimization to manage the large volumes of data and queries they handle. However, the paper does not suggest using traditional relational database systems for search engines, but rather adapting and combining different principles from databases and systems to design a more efficient search engine. Challenges. The below are the challenges. Ranking documents. The ranking documents refers to the process of determining the relevance of a document to a user's query and ordering the search results based on that relevance. Search engine uses various algorithms and factors to rank documents, including keyword frequency, page authority, and user engagement metrics. Ranking query results. Similar to ranking documents, this refers to the process of ordering the search results for a given query. However, in this case, the ranking is based on the relevance of the query uh, itself to the user intent, rather than the relevance of individual documents. Search engine use techniques like query examination and the user modeling to improve the query ranking. Availability. In this context of search engines, availability refers to the ability of a search engine to retrieve and serve search results to the users. This can depend on the factors like serve uptime, network latency, and the data center location. Ensuring high availability is critical for search engines, as users accept to receive search results quickly and reliability. Freshness of data. This refers to how up to date the information in the search results is. For example, for some types of queries like news or the weather updates, freshness is very important, as users want the most recent information available. Search engines uses various techniques to ensure freshness, including crawling frequency, updated pages more frequently, and using time-based ranking signals. Contribution. The main contribution of this paper is the presentation of a design for search engine using the ideas and vocabulary of a database community as a model of how to design data intensive system. And also the paper argues that search engine should have to use the principles of databases but not the artifacts, and on the other hand a novel data intensive system should do the same. Approach. The approach taken is to combine the principles of system and the database to design the data intensive system like search engines. And also the author suggests that search engines should have been designed using top down design, data independency, and the declarative query language principles from databases. However, instead of using traditional database implementation, the author proposed creating application specific data system that exploit database principles. And also, the author argues that while search engines have many similarities to databases, they also have unique characteristics that require a different approach to design. By combining principles from both systems and databases, the author suggests a new approach to design a data intensive systems like search engines. This approach involves using a top down design, a data intensive, and declarative language principles, but building application specific data systems that are optimized for unique needs for search engines. And also the author believes that this approach will lead to more efficient and effective search engines and may also be applicable to other types of data intensive systems. Validation. The validation of the paper comes from several resources, including almost 9 years of work on Incoteam search engine from the summer of 1994 to the spring of 2003, as well as the experiments performed on other major research engines such as Alta Vista, Infoseek, and Google. The author also presents experiments performed in 1996 on Informix, a database management system that had cluster support. The result of this experiment showed that the hand-built prototype for the search engine was an order of magnitude faster than the implementation of Informix. The authors attribute this performance difference primarily to the another of a specification that could be applied in the hand-built prototype, which was not possible with Informix. Overall, the experiments provide empirical evidence for the effectiveness of the approach suggested in the paper, which combines principles for system and the database to design data intensive systems like search engines. Conclusion. Finally, this paper proposed a new perspective on building application specific data systems, starting with search engines by leveraging database principles while deviating from conventional database implementation. The paper presents a design for a search engine using the ideas and terminology of the database community as a model of designing data intensive system, and that top-down design with a data independence and declarative languages which employ the principles of databases are a good fit for the data intensive systems, but they do not match well on the SQL and existing database semantics. The example systems discussed included search engines, logging systems, distributed file systems, workflow system, XML databases, and bioinformatics. Thank you.